Wee woo. I am back. Back in black, as some would say. Well, still pretty white, but you know what I mean. Hold on, I need to take my shirt off. I don't know why I don't do this before stream every time. Excuse me. Every time, dude. Okay, there we go. So, following plan. I always have a plan. Almost always. Usually. Sometimes I sometimes have a plan. Plan is to learn SQLite. Clyde, as some would call it. So we can... List of C language APIs. That's a lot. Probably don't care about any of these. I want to know where I can download it. This is not it. Bugs, news, prior releases. Oh, I found it. SQLite.h. The name of the branch from which the source code is taken. Can I just apt install it? Let's see. We're gonna figure this one out. Man SQLite. Okay, doesn't exist. Unlucky. How to use SQLite 3 with C. SQL. Okay, I got it. And okay, I think I can just download it. So yay. SQLite. SQLite 3, no? It's already installed. Gotta love my system. No idea what's going on. Ooh, the bots are back. Get banned, idiot. Okie dokie, so if I do dash SQLite three, my bad. Dash SQLite 3. Okay, there we go. We found it. So let's see. We got all of this stuff. What do we actually want to start out with? I feel like we want... Should we start with users or should we start with chat? Which one would be easier? I think we should start with users. Right. What do we need for users? We would need... Actually, let's draw it out. Do a little sketch. Little sketching. Math. There we go. This one gets hidden. I should at some point make a new one, I feel like. Okay, so basic plan. We have users database. Users. What do we need? We of course need user name. Okay, so far so great. We probably should store the session ID. Can we add columns afterwards? SQLite edit add column alter table. The add column syntax is used to add a column to an existing. Okay. Let's just start with username and session ID. Oh, we need a password. We do need a password, don't we? Oh, if we want to use OAuth, I don't even know how that would work. Do we need an email address? I don't know. Maybe we should just use OAuth. What the fuck did I just press? OAuth. What does it do? What is and what does it do? Principles of OAuth is an authorization protocol, not an authentication. As such, it is designed primarily as a means of granting access. Okay, I don't think that's it. Grants a set of steps a client has to perform to get resource access authorization. Happen on a server side. The authorization code flow might be used by single page apps. However, here the client secret cannot be stored securely, and so authentication during the exchange is limited to the use of client ID alone. ChatGPT. Because we are learning. Hi. Because we are polite to the bots in case of an eventual uprising. Hi. I want to build a website that has... What does it have? That has a login. Is username and password still a viable option, or are there better ones? Let's see, because I don't know. Still viable, but it's no longer considered sufficient for good security. Modern best practice is to either strengthen or replace it with better authentication methods, depending on your use case. Username password, still viable, but easy to implement, familiar to users, works everywhere. Okay, got that. Weak reuse passwords, bro, that's a you problem. Phishing attacks, I don't even have your email, so I don't know how that would happen. Credential stuffing. Bots trying leaked passwords. Yes, if you use unsecure passwords, again, I assume my users are idiots, so they will all use unsecure passwords. Insecure. No. Unsecure, no? Unsecure versus insecure. Versus something that's not protected or safe. Okay. Insecure. Okay. This is unsecure passwords. I know what I'm talking about. Recommended. Password plus something else. Multi-factor authentication. Okay, email. Fuck that shit. I'm not gonna do that. I would have to build an email server or something. Sounds bad. Authenticator apps. Ooh. Now we're talking. No, don't know how that works, but most production apps use this. Passwordless login. Ooh. Modern trend. Magic links. One-time codes and pass keys. Magic links. I don't like them. I don't think. Do I? How many people can use passkeys? Is that actually like viable? Passkeys are quickly becoming the gold standard. They use biometrics, fingerprint/face, device-based authentication. Huh? Okay. No passwords to remember, phishing resistant. Slightly more complex to implement. Some users don't fully understand it yet. Okay. Balanced and recommended. Username, email plus password. Optional multi-factor. Offer passkeys as an upgrade. Passwordless. Just use passkeys. Option C. Multi-factor required. Some passwords with store password with hashing. Add rate limiting and bot protection. Why would I store? Hello, okay. Passwords with hashing. I don't know. We will find out. Never store them in plain text. Okay. Good to know. I would have just done that. Ooh, but if the server gets hacked, then they all have the passwords. Okay. You store a password like this and your database is leaked. Okay, yeah, bad. Instantly know the password, can log into the site. Try the same password on email banking. Yeah, that would be bad. Okay, I do agree. Hashing transforms a password into a one-way fingerprint. Key properties. You cannot reverse it back to the original password. Same input always produces the same output. Same with the same salt. What is a salt? Oh right, it's the... You put a string at the end and then you get the salt. I know things. Okay, you hash the password. You store the hash. Users log in, they enter the password, you hash it again and compare the hashes. Never need to know the actual password. But I do get it though, right? Or do they send the hash automatically? No, then you could hack it again. Yeah, don't send the hash. Random data per user. It ensures. Use Pre-computed tables, rainbow tables. So you add salt. Random data per user. Okay, why use bcrypt or Argon 2 specifically? Not all hashing is equal. Too fast, easy to brute force. Bcrypt or Argon 2. Slow on purpose. Okay. Fuck my server, I guess. Instant disaster. Attackers must crack each password individually. Strong password may remain safe. Okay. Storing a log that only matches the key but doesn't reveal it. Okay, I assume I want to store them with hash then. So, hold on, I got this. Okay, so we want to... What? Brush. I want to store a password hash. Okay. Then we want to use the keys. Okay. What would a server need to do to handle passkey authentication? Asking the real questions. Based on web authenticate plus Fido2, no idea what that is, shift a lot of responsibility away from passwords. But the server still plays a critical role. It doesn't store secrets like passwords anymore, but it verifies cryptographic proofs. Oh. Here's a clear breakdown of what the server actually needs to do. Hold on. Excuse me. Okay, passkey is public-private key pair. Private key is on the user, public is on the server. I only store the public key, not the secret. That makes sense. Registration, why are there two main flows? Oh, registration and authentication. What? I may ignore the two main flows. Creating a passkey. User clicks create account or add passkey. Server generates a challenge. Random one-time value. User info. ID username. Wait. Why do I generate that? Shouldn't the user give me the username? That seems the wrong way around. Relying party info, your domain. What? I don't understand what they want to tell me here. Server sends this to the browser. Yes. Browser and the device create the key pair. Okay. Signs in the challenge with the private key. The client sends the response back to the server. The server verifies. Challenge matches, origin is correct, your domain. I don't know what the fuck that means. Signature is valid. Cool. Server stores public key. Credential ID. Oh, wait. I mean, you mean the username, right? And metadata. Optional. Authentication. User clicks login server. looks up user via username, email. Discoverable credentials, yes, because that's the... Yeah, makes sense. Generate a new challenge, we send the challenge. They decrypt the challenge, send the signs the response, sends it back. Server verifies the signature. I don't know how signatures work. Who cares? Challenge is correct, the origin is correct, credential ID exists. If valid, user is authenticated. So I need the credential ID, the public key, user ID, and sign count. Optional device info. Huh. What the server must verify. Challenge matches. Yeah. Origin, your domain, prevents phishing. Cool. Signature is valid. Proves device ownership. Credential exists. Sign counter increases. Don't know what that is. What I don't have to do anymore, password hashing, passwords resets, no credential stuffing protection. Libraries you should use. Don't build from scratch. Okay, it requires HTTPS, but I don't have that on my backend, so we're gonna ask. I have an Nginx server with HTTP/1.1 backend. Written in C. How would I implement that? What do I need? Is there a library for that? There's no widely used mature WebAuthn passkey library written in C for servers. What? Why Java, Node.js, Python? That's cringe. Stop it. Get some help. YC is tricky here. WebAuthn is not just crypto. Server must handle binary JSON-like format, certificates, signatures. Ugh. Your realistic options. Run a smaller sidecar service in another language. Fuck that. Stays clean and simple. This is the most common real-world approach. Can build it yourself? Okay, that's not happening. Roll your own, only if you enjoy pain. If you want pure C, a Seaboard parser, base 64 URL. Fuck that. Okay. Practical recommendation based on your setup. C handles business logic. C is the businessman doing business things. Definitely not a cop. Auth service handles web authentication. Okay, cool. What does the standard 2FA API look like? Do I need 2FA? Are we serious right now? Hold on, let me check something. I can just sign up with whatever the fuck. This OAuth. Then I don't have to deal with any of this, do I? 2FA, single... Bruh. TOTP. Sounds based. Okay, cool story. Can I simply use OAuth and not deal with any of this? Now we're asking the real questions. Yes, you can avoid building your own login system, but here's important nuance. OAuth alone is not authentication. What you actually want is OAuth plus OpenID Connect. Give app access to my data. This is who I am. For login, you always use IDC on top of OAuth 2.0. If you want to use a provider like them, they handle password, passkeys, all that shit. What the flow looks like. The user clicks login with X. Do they mean Twitter or do they mean like any random? You redirect them to the provider. Authorize client ID. Cool story, bro. Provider handles login. User is redirected back. You get a code. The server exchanges code for tokens. Wait, what? Who gets the code? Hey yo, Kaiser Blue. Currently learning how login works. So we have several options. I need some opinions over here. Let me make a list. Okay, list is in blue. So we have user name and password. Okay, that's a simple one. What's happening? I'm working on the website, on the beautiful looking website. We need to have users actually log in. Oh, it's not running the API, so that they can use chat, you know. So we have username plus password. Very simple, apparently. Then we have the option of using OAuth plus something. Also, let's see, hold on, let me... Green. Very simple, apparently. Pretty simple. Then we got some stuff like 2FA. Complicated. And then we got some stuff like pass key, for which I would actually have to use a different language because no one is implementing this in C for some reason. Fucking pussies. No one writing a library for crypto and all the other shit. And yeah, so in case 2FA is the thing where you need to pull out your phone every time, you probably pair that with username and password. Then we have OAuth, where I don't have to deal with any of this. You just click on the I don't know, does Amazon have this? No, they don't. Who does this? I think ChatGPT might actually do that. Hold on. If I click login. Yeah, continue with Google, continue with Apple. Then they redirect you to Google, where you have to sign in Google, and Google will tell ChatGPT, oh yeah, that guy, I know that guy. So I wouldn't have to do with any of this, because they do the login, apparently they get a code, server exchanges code for tokens. I receive an ID token and an access token. I verify the ID token, check signature, check issuer, check audience. Don't know what that means, we will find out. Validate the tokens. Create my own session, I can do that. Map the user to my database. No passwords, no 2FA, no passkey. No pesky passkey. Pros, much faster to build, much more secure, done by experts. Yeah, I am not one of those. Built-in multi-FA, less liability, depends on third party, users need external account, slightly more complex flow. I have to disappear again, just wanted to drop by and say hi. Okay, have fun. Common architecture. Cool. C backends handles login, handles callback. Verifies JWT. Okay. HTTP client to call token endpoint. Some verification. Implementing web authentication or full authentication. If your goal is, I just want login to work, use OAuth, best choice. I want full control, no dependency, 2FA plus password or passkeys. I like low-level control. Okay, optional email password is, oh, yeah, that sounds great. Based. So, Is there a library for password hashing? Use argon2, lib argon2, that is straightforward. Example simplified. ID, time, cost, memory, cost. Winner of the password hashing competition. Designed to resist GPU ASIC attacks. Memory hard. It's hard. Bcrypt older. Cringe. Built-in option. Unix, Linux, use crypt with modern schemes. Wait, what? Less flexible than dedicated libraries. It's built in though. Why wouldn't I use that? Don't forget to salt. Automatically generate and store salt in the hash string. You store this whole string. Hash, password length. Library provides verify functions. Ooh. Let's just do login normally, right? With password and hash at the start. You can always switch later or add later. So username, session ID, password, hash. Oh shit. Do I need to do email verification or something? That would be annoying. Let's just do that. Okay. So, what do we want to do? Create the database. That sounds like a good first step. SQLite light. Create table. Oh, create database server. That one. Create database. It sounds like a good first step. Nope. SQLite DB evol. That looks complicated. TLC, dedicated CLI. Okay. GUI my ass. Starting CLI. By typing SQLite, I can do that. SQLite 3. Optionally followed by the name of the file that holds the SQLite database. If the name file does not exist, a new database file with the given name will be created automatically. What do we call it? Because I am very much not creative. That was the wrong button. We call it... Do we call it database? That sounds fucking stupid. I do want to call it database though. Hold on, let me... Actually, Vim... I want... Create... Is there a space here? Create... Database... What is H? So SQLite database. No. Bro, we need a better name than this, right? Fuck it. Database. SQLite 3 actually. And of course we need to do this /bin/sh. Terminate the program by typing your system end of file character to stop a long-running SQL statement. Oh, you automatically enter into this. But how do I write a script then? How would I do that? SQLite shell script. Has to be a way, right? This is not it. This is not it. Do I have to pass in EOF or something? Line structure, weird shit, control of line endings. Redirecting. Edit, import files as CSV, export to Excel. Converting an entire database, recover data, loading extensions, cryptographic hashes, archive. Using it in a shell script. One way to use SQLite in a shell script is to use echo or cat to generate a sequence of commands in a file, then invoke SQLite while redirecting input from the generated command file. This works fine and is appropriate in many circumstances. But as an added convenience, SQLite allows a single SQL command to be entered on the command line as a second argument after the database name. Okay. So how do I create a table? Create database. Okay. Dot databases. Create table. I forgot everything about SQL, dude. Okay, create table if not exists. Create table, okay. New name of the table, database in which the new table is created. Name of each column in the table. Declare type of each column in the table. Ooh, we're getting spicy. Text, numeric, integer, real. What is real? Create table with examples. Create table schema.name table name. Okay, so we have this. I can apparently put a command afterwards. Create table users bracket column 1. I should feed the actual. You know what? We're gonna do it the better way. Hello? We're gonna do SQLite 3 database. Now we're gonna try some shit. Create table users. Then we have brackets. Create table users, brackets, column 1. These are not the names, are they? Data type, primary key, not null. What? Oh, primary. Ah, I remember what primary key is. Okay. Second, use if not exist option to create a new table if it does not exist. Third, optionally specify schema name which the table belongs. Don't know. Column list. Each column has a name, data type, and constraint. Primary key, unique, not null, and check. Fifth, specify the table constraints, such as primary key, foreign key. Finally, optionally use the without row ID. By default, a row in a table has an implicit column, which is referred to as the row ID column. The row ID column stores a 64-bit signed integer key that uniquely identifies the row inside the table. Table with that contains the row ID. Note that is or a group. What? Note that the primary key of a table is a column or a group of columns that uniquely identified each row. What the fuck does the row ID do then? Hello? Primary key. One column, you can use the column constraint. I don't care. Okay. Column. Ah, this is the name, so this is user name. I got this, guys. Right, can I do... Yes, thanks. User underscore name text primary key integer text. I forgot. Session ID. Ooh, what is that? Integer, right? SQLite int length. Data types null base integer. I'm gonna make you to real as a floating point. text blob. The integer storage class, for example, includes 7 different integer data types of different lengths. This makes a difference on disk, but as soon as integer values are read off disk and into memory for processing, they are converted to the most general data type, 8-byte signed integer. And so for the most part, storage class is indistinguishable maybe any column except an integer may be used to store a value of any storage class. What? I can store text inside this? Whether they are literals embedded in SQL statements or parameters, database engine may convert values between numeric storage. But 64 is not enough, is it? I would need... You're doing some Arduino stuff? No. I'm doing web dev stuff currently. Do I store it as a string? That would be so cocked. I don't want to store it as a string. I want to have 128 bytes. SQL. How to store 128-bit int. Does not have. Oh. Can I? Oh, I can do binary, right? Resulting affinity int. Unsigned big int. The fuck is unsigned big int? Following table shows how many common data types names from traditional SQL implementations are covered into affinities. Big int, small int, tiny int. That's average, right? SQLite. That does not work. It lets you do a range comparison on a blob. Uses memcopy to do the comparisons. Insert your data in a format that can be compared correctly using memcopy. You should be fine. Session ID. What are common session ID tokens, token types. Are they integers or strings? Make random strings. Session ID. Examples. Dun, 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 dun. Just random bytes. Stored in database or memory. Example, base 64, random bytes. Simple, secure. Dun, 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 dun. How do I store random bytes in SQLite? Asking real questions now. Blob. Session ID blob not null. Okay, I can do that. What does not null mean? These columns are not null. That means you must provide values. Huh. So I always have the latest session ID, huh? I guess. Session underscore ID blob not null. Cool story, bro. What else do we have? Password hash. What are password hashes stored as? I don't know. Are almost always stored as strings. It's intentional and very useful. Stored password hash actually looks like... Oh, interesting. So this is text. Password hash text not null. Okay, I think we got this part down, no? Not null, oh, and bruh. I want to say unique. SQLite database. Damn it. I have to start again. User. No. Create a table. Users. User underscore name. Text. Primary key. Session underscore ID is blob not null unique. And we have... I forgot. Right. Password hash text not null. Ooh, yeah. Okay. Then we close the bracket and semicolon. So that works. So can we now add a user? Dun, 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 dun. So SQLite add entry. That seems simple. Shit. How do I get my password hash? Create password hash. What is it? Argon or something? Argon 2. Argon 2. Bash. What the fuck is that? Argon 2 parallelism. What? Number of threads used during the hashing process which can enhance performance. Bruh. Can improve the speed of hashing but may also affect security as it allows attackers to utilize more resources in brute force attempts if not balanced with memory and iteration settings. Bitwarden community forums. Dun 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 dun. Good Argon 2 settings. Interactive logins. Memory cost 64 megabytes. Latency, GPU resistance. Huh? Okay. Iterations 3. Memory cost 16. I assume this is megabytes. Hash length 16. Oh, that's the Argon ID. I don't... What? Help. The Linux crypt Argon crypt key salt stuff. I heard ChatGPT gave me an Argon library or something. Argon 2. Argon 2 IBT. Lip Argon 2. Lip Argon 2. That's something I download. Yay. Lip Argon 2 is already installed. Nice. So what is, how do I dash L Argon 2? Yes. Nice. So can I vim login.c c use lib argon 2 reference implementation argon2.h. I assume I have it include argon2.h. I assume I have that. I do. Okay. Nice. Ooh, that is a lot. Argon hash raw. Why do I have a low-level API for this? Cost. Password is the string duplicate password. Okay, I'm gonna make it easy. So let's see. We have our int main. Watch me. Okay, I got this. Constant char pointer password equals password. We are reaching critical levels of password security right now. Then I'm just gonna copy this. Hello? Okay, I might be stupid. So the cost was time cost, 2 bars. This guy says I should use ID. No idea what the fuck that is. Let's see. Hash 1. Hash length. I don't think this is helping me a lot, is it? Choosing parameters. 3 iterations, 1 parallelism. I can do that. We're gonna do 3 and 1. Then we're gonna have some fun. Where's my 64 maybe bytes? So what was this example? 16. So 1 shift 16. Password is password. Password length is string length password salt. Salt is 0. What do I get as salt? Used to fold any additional data into the hash value. It's almost exactly like the secret or salt parameters. Lib argon. There has to be a man page, right? Man and lib argon. That did not work. Argon 2. No. Fuck did I? Man. Argon 2. ID? No. Okay. Just doesn't exist. Based. Who doesn't love it like this? Has to be a wiki, right? No? Okay. Why would there be a wiki? Am I right? What is this? Where's my source? Is it this? Racket. Argon. Lib argon 2 as a racket package. No, I want this. Source. argon2.h. Probably in like headers include. Yes. Oh, there's a wiki. Oh, wait. Bruh. Usage, make builds, okay, static library, cool story, argon 2, salt iterations, memory parallelism. Where's API? Low level and high level functions. Secret parameter. This is not helping, is it? To use argon 2D instead of argon 2I. Got argon 2D. Argon 2ID. Ooh, that sounds like what I want, right? ID. Then I go to this. F argon 2ID. Raw. Parallelism. Password. Password length. Constant void salt. So this does not give us a salt. Salt. Can we generate a salt with this? Fix memory blocks depending on password and salt. Encode length returns the encoded hash length for given input parameters. Minimum and maximum salt length in bytes. Salt too short. Salt and its length. C generate argon 2ID salt. Random char. Oh, I need random stuff. Oh boy. C, random. Int value rand. Save random, is that safe? What is a safe way to generate a random salt? Wait, no, I don't want random salt. Does it have to be the same every time? Random salt in C. Must be generated using a cryptographically secure random number generator, not rand. Yeah, that's what I thought. Linux, Unix. Get random. Best modern choice. What do they do? Men set salt to 0. Based. Let's see, what happens if I do 1, 2, 3. Password. What does this look like? Argon 2 ID B19 M16 T3 P1 This is the hash. How do I handle salts? Do I use the same salt for every user? If not, how do I save them? Each password unique salt. Okay. Clearly the salt is not a secret, but must be unique. Restore salt. Inside the hash string. Ooh, does this do that? Oh, I think it does. Interesting, interesting. So that way I can generate myself a random thing. Int 8 underscore t salt. Oh, where do I do the brackets and see? Salt, like here, equals. What did ChatGPT tell me? Oh, salt length. Should I also randomize that one? Would be funny. 16. Right. Actually, constant char pointer generate or gen pwd underscore. Can I do this correctly? Gen pwd hash. And what do we give it? We give it a constant char pointer password. And that's it. Okay. Okay, we have the salt. We do get random. And for that we need sys random. Oh. Never mind. Okay. Include sys/random .h int red int error equals that. If error red, this is, oh, we return the size of. Size of salt. That is not equal. So let's not call it error. Let's call it size. Size. If that return 0. Okay, we got our salt going. Actually, we're gonna put in the hashtag define salt size 16. Salt size. Okay, we got the password, which is actually pwd. We got this, which is actually pwd. We got the salt, we got size of, yeah? Size of salt. What is hash 1? What's hash 1? What's hash length? Oh. This doesn't tell me anything. Makes it so that the algorithm scales very badly. Thus, 2 to 3 seconds of argon are much better than 2 to 3 seconds of something else. That being said, a 20-digit high entropy master password, you are safe. Okay, there's a bunch of cool shit. I want to know how long should my hashes be? Because that seems important. Okay, 2 to 4 is common. Parallelism. For typical web apps, okay, we're at 64. Salt, encoding, secure storage. Concurrency and queuing, performance testing and adaptive configuration, library choice. Hash length. Length. Why can't I spell that? It's enough in this case, which seems pretty true, but okay, 256 bits, which is 256 divided by 8, of course, 32. Hash. Hold on. If we generate it in here, it will get freed when we exit the function. We kinda need that hash. Oh, no, wait. Do we? Who knows, actually. Dun, dun, dun. That was not what I wanted to... That's what I wanted to press. argon to ID. Argon public. Let's see, what do we have? Hash length, char pointer encoded. So we have the hash length and we have the char pointer to something. Now the problem is do we need to free that or... Oh no, wait, we give it the pointer. How do we know how long it is though? What is the example doing? It does not... What? Wait, what's hash 1? Oh. Da 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 da. So we give it hash 1, which is hash length long. I thought we would get a string or something. Argentine, blah blah blah. Let's just try what they did and see what happens, I guess. So we want to do the same thing here, but with hash size. Hash 1, hash length, print f %s \n hash 1. Okay. Get pwd hash of password. Oops. Hash length. Yeah, that does not exist. I do agree. Hash. Why is this case sensitive? I give up. I'm gonna do it manually. Bruh. Hash. Oopsie. Oh, I have caps lock on. That's the problem. There we go. Hash underscore size. Right. Return char pointer 0. Oh, gen, not get. My bad. My bad. Oh. Okay. Well, it gets me something. But not what I want exactly. Type 2 string gives the string representation of the argon type. Program type. The argon type we want the string for with a certain degree of parallelism. Pointer to the argon internal structure. Uppercase whether the string would have the first letter uppercase. Why would that be? Okay, but what is the type? Argon 2 type. 2. Argon 2 underscore ID. But where do I feed the... Where do I feed the function the actual hash? What? Okay, I can give you the type to string. We're gonna see what the fuck is happening here. What was it? Argon 2 underscore type to string, not string. Then we have argon 2 underscore, yeah, ID. Some reason spelled with a capital A, I think. Yes. 0 or 1, I guess. Who cares? Now we want to... Oops. We want to print f a string with a line break with that as a string. What am I looking at, bro? Can I? That was not... Yes, it's a warning, who cares? Argon 2 ID. Bruh. Okay, that's not what I wanted. It just prints me Argon 2 ID. That's fucking pointless. This gives me the encoded hash. Hash raw. Oh, wait. Yes, I want the encoded, not raw. So I want this argon 2 hash encoded. Alright. And you have the normal stuff, salt length. Then we have not the void hash, we have the hash length and the char pointer encoded. But I would need enough memory for this. No? Or does it allocate by itself? Let's see. Encoded. Using an encoded hash. Encode length, the size of the buffer. Okay, so I can have a buffer for this, which I'm gonna make hold on, how do we make that? We want to create the buffer outside of this. This is annoying. Outside of the function, really? Broski, Brozev Stalin. Okay, fuck it. Guess we're doing it that way. So u int 8 underscore t encode size 104. Kinda want to do that on the heap though. Uint 8 underscore t encoded hash let's go that way. It's nothing, it's consistent anyway, so we're just gonna do like this. Encoded hash equals... Oh, wait. Pointer. U int 8 underscore t malloc and what the fuck did I call that? Encode size. Encode size. Okay. Then we give you the what do we give him? We give you in int 8 underscore t pointer. No, this is just a char pointer, actually. I have decided. Char pointer. Char pointer. Buffer. Actually, we're gonna just call it buff because I'm better than that. And you return fucking int. I have decided. -1. -1 actually. I just want to get it right. Why am I fixing stuff that doesn't need fixed? Okay, that's gone. We just have salt length. Oh, encoded. Salt length, hash length, char pointer. Buff. And encode length, which would be encode size. Right. Okay, let's get this out and we're gonna print f % as backslash n encoded hash. And you also have the encoded hash. Oh, encoded hash. Whoopsie. Yep. I need to get the setting that lets me start the Vim file wherever I left off. Huh? What's the problem? Gen pvd hash 1 unused. That is true. Pointer target. Oh. God damn it. You are also a char pointer. That's not what I wanted to do. And now we run this and we get an actual thing. How long is this? Want and another. $77. I can drastically reduce this size. 128 maybe. 256. Let's be safe. Don't want any dumb errors. Okay, so will this always be the same length? Who knows? Hey yo, how you doing? Back so soon, huh? So I have decided that cryptography is fucking ass, by the way. What is this shit? Actually, I don't need to resave, it's the same length every time. 1, 2, 8. Yes. Works. It just works. Okay. So. Now, the plan is to... Oh, I need to still get How do I do SQLite stuff again? So I want cryptography. Yeah. Luckily I don't actually have to do the cryptography. I just have a library that does it for me. Because fuck that. It's generally not recommended to implement that yourself. Just because it's really easy to have some errors and not consider one thing, which makes all the cryptography very easy to crack. Or you are Apple and hold on. Apple M1, I think. Prefetcher crypto. Leak secrets, yeah. So, as far as I understand it, okay, I don't even know what that means. I'm stupid. Cryptography, basically encryption. If you want something to send to someone but don't want people to listen in, you have to encrypt it. But basically, hold on. Let's see if I can get this back together. So, Apple has this M1 chip, right? And basically, a chip has, like this is the chip with the arithmetic logical unit, right? Then you have a bunch of caches, C1, C2, C3, that doesn't matter right now. Then you have your RAM. Now the thing is, fetching things from RAM to your cache so you can use it to make some calculations, you know. This line here, this takes a lot of fucking time. So basically, what Apple thought was we're gonna have a tiny unit in here. This looks ahead in the code, and anything that looks like it could be in RAM, a RAM address, it just puts it into the cache before the code gets executed. That way it's in the cache and we can immediately use it for the calculations. Do I have touch on my fucking graphic tablet enabled? Okay. So basically, seems smart, right? We have the prefetcher over here. Makes sense. Now the problem is crypto algorithms, they need to always, no matter what you put in, take the same amount of time to execute. Otherwise, you can kind of guess what's going on, and based on that, guess guess what the keys are to decrypt your drive or something. So what researchers did, they just had a program running that would just use some random numbers that looked like RAM addresses, so the prefetcher would get them and put them into the cache, and depending on what addresses you fetched before you executed your algorithm, the time would change. So you kind of knew, oh, this RAM address seems to be really important. And then it took like, I don't know, 8 hours or something for that thing while using the MacBook. You just have that thing running for 8 hours in the background, and then you could just decrypt the drive. And this is a hardware bug. Like, you bought the Apple laptop, unlucky. That's just, you can't fix that. I think they had some weird software workaround in the end, but yeah, that was funny for everyone but Apple and Apple users. Where was I? Right. Documentation. Programming interfaces. 5 minutes or less. Yes, that sounds great. Okay. Why do I have a callback? Okay, apparently we need a little bit more than that. So, open a connection to a database. Open jar file name. And something. What are we doing here? Okay, we need to include this. I can do that. SQLite. Also, you can't just use any random number generator. Like, you can just use random, but apparently that's not safe to do with cryptography. Apparently you can guess that random number. But sys/random, that's something different. That is safe. Don't ask me why. Okay, we got a bunch of weird shit over here. Okay, that's the generate password hash. Let's do the SQLite. SQLite 3 pointer called database. Okay. Error message, don't care. Right, you can get error messages. Int rc, I assume that's the file descriptor or something. So we're gonna call that int rc, because I am creative. I know. What else do we do here? I'm gonna get a couple of weird stuff. rc equals open. I can do that. rc equals SQLite open argv1. Oh, that's the location of the database. Trust me, bro. That will work 100%. Okay. Wait, RC is a return code. I have something for that already. Right? Maybe not. Okay. Now we check for errors. If RC is anything but 0, we print p error. Actually, that's what we're gonna do. Failed to open database. Right. Okay. And then we return. No, we go to something. No, we return actually. That's what we do. 1 base. Or am I stupid? No, I am not stupid. I am just mostly stupid. Okay, yeah, I don't care about the error checking right now. That's something we do when we actually have something working. Okay, we open it. Then we execute. And for that we do need char pointer z error msg equals 0. Database, yes. argv2, that's not what we're gonna put in there. We're gonna put something way better in there. I know what we're gonna put in there. Okay, watch this. I did not think this through. Constant char character pointer add user equals. Hello, there we go. Now how does one add a user? I have no idea. Insert into user makes sense. Insert into users. Now I immediately forgot what the fuck the column names were. Or the order of them. I believe username. We're gonna call you test user. Yes, I'm creative, I know. Session ID. God fucking damn it. Can I get a random value? CW session underscore ID. How big was that again? I forgot. I asked ChatGPT, right? $32. Yeah, that makes sense. 32. In session ID. Size of. Oh. I need to salt gets changed to session ID. There we go. Based, and you get shit. All right. How do I input blob values? SQLite insert table blob. Title vchar not null. Okay. JPEG image. What is happening here, huh? ID, title, data. Oh. Is that how you do it in C2? Execute database argv callback 0 error message. We're gonna need to check out the documentation. Must have compromised essential elements. Open, close. The prepared statement object. Constant statement. Huh? Interesting. Okay, open, paste, prepare, compile text into bytecode. We'll do the work of querying and updating. Where did I prepare 16 v3? What the fuck is this? Wrapper function that does prepare, step, column and finalize for a string of one or more SQL statements. Okay, how do I do prepare? It converts SQL text into a prepared statement object and returns a pointer to that object. Okay, but what does that look like? Okay. Type def struct SQLite stmt SQLite 3 stmt. An instant of this object represents a single SQL statement and has been compiled into binary form and is ready to be evaluated. Think of each SQL statement as a separate computer program. The original SQL text source code as a prepared statement object is the compiled object code. Okay, database handle, SQL statement, UTF encoded, maximum length of ZSQL in bytes. Out statement handle. Ooh, get banned, nerd. Pointer to unused portion. What? Those routines are constructors for the prepared statement object. The preferred routine is to use prepare v2. Okay. Cool story, bro. Interface's legacy has extra Wrap flags. DB. Oh, we can open V2. In the native byte order of SQLite and Open 16 database connection. Oh, we have flags. I don't care the flags. No sleep, getting a bit sick. Oh, again? Damn, bro. You're really unlucky. Well, have a good night. And, you know, get well soon. We do. Take care, take care. The flags must include, at a minimum, one of the following combinations. SQLite, open, read, write. Where was I preparing a statement? Bind the values to parameters. Is there like an example? Oh boy. How the fuck? I want an example, please. Okay, bind store application data into parameters of the original SQL statement text input. Literals may be replaced by a parameter that matches one of the following templates. NNN, no, not November, represents an literal integer, literal, alphanumeric identifier. The values of these parameters, also called host parameter names, can be set using bind. Okay, so what do I want to do? I want to... Oh. User name session ID and I forgot. SQLite database dot date tables users dot columns fuck. Command. I swear there are dot commands. I knew it. Dot help. Schema? No. Bail TD changes databases. SQLite get table schema. I don't know. I don't know what a schema is, bro. Dot schema users. Oh. Yeah, that's what I wanted. Session ID, password hash. I immediately forgot password hash, yes. Bro, the ADHD is strong today. Password hash. Values. Now what do we want for values, huh? Insert into artist backup. Wait, where was it? Here. Not this one. Oh, I forgot. Which tab I was in, bro? Oh, this was the one I wanted. Values question mark, question mark. What does that mean? Bind? Question mark. Integer literal. Alphanumeric identifier. Bind blob. So... Oh wait, no, I can actually set the username in here. Test user. I think I can do enter, right? No, I can't. Can do \enter. I can. Interesting. I did not know that. Okay, test user. Session ID will be a blob. So a question mark. Password hash will be text. Which I also want to do later now. First argument to the SQLite bind routines is always a pointer to the statement object returned from prepare. The second argument is the index of the SQL parameter to be set. Leftmost is 1. The same parameter is used more than 1 second and subsequent occurrences have the same in what? Leftmost SQL parameter is 1. The same named is used more than once. Have the index of from named parameters can be looked up using bind parameter index. API if desired. The index for NNN parameters is the value of NNN. In 1 and limit. Good. Question mark, question mark. See if that works. Now we open that. We don't execute actually. What we want to do is we want to prep or prepare? I don't remember. Prepare underscore v2 underscore v2, which has db. Let's see, db constant char the statement, the length of the statement. So db, then we have add user string length of add user what else? Okay, and byte out statement handle. What? Read up to the first 0 terminator. 0 terminator, n bytes have been read, whichever comes first. If n byte is 0, then no prepared statement is generated. But note that supply strings is null terminated, then the performance advantage that is the number of bytes in the input string including the null terminator. Yeah, but string length probably negates that. So -1. Okay, now we have pp something. If pztail is not 0, then pztail is made to point to the first byte past the end of the first SQL statement. Can I set both of them to null? PP statement, out statement handle. Do I have the... Oh, int. So I need to struct. Oh, they have type defs, don't they? SQLite statement. I don't like that. Statement pointer. I think I might need to statement. I don't know if I need to set this myself or not. This is a pointer, right? Okay, then I don't think I need to set this myself. Statement. Null. Okay. Now, I just... Damn it. I hate that Vim overrides your... your what? Your clipboard. That's all. Wrong. Finding words, I swear. Can we compile this already? The error message is unused. That's a shame. Fail to open database. That's unlucky. No search file or dictionary. Why? It's clearly here. Database. No. /home/users. No, /home. Mer. I got this. Git alex-site/API. That also didn't work. Database. What is your problem? I don't even reach that. This fails immediately. Why? What is happening? Dun, 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 dun. File name. URI file names. File name argument is interpreted in UTF-8. Okay. don't know what's happening here. We should clearly be able to open this. Maybe I have to do arc V1. Maybe I need to constant character pointer db path equals dot slash database and you will be dot db path. That was also not the problem. Database. This is kind of annoying. Now what I'm gonna do the arc-V thing. Arc-V 1. Okay, that's not the problem. For some reason. No, actually, I'm gonna try the full path again. Maybe I just fucked up some spelling somewhere. /home /mer /git /alex -site /api /database. Nope. What is happening? You're clearly here. Do I need to... what's read write? That would be... 6. No, that's not the problem. Da, 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 da. Simple C is how to use interface to SQLite. The name of the database is given by the first argument, and the second argument is one or more SQL statement to execute against the database. Function calls to page retention drawer are SQLite open, exec, and close. SQLite. Hello, can you type? SQLite. Wood easy bunning broski. Passing a URI, I don't pass URIs. Maybe I need to move database to database.db. Who knows? Maybe we're complaining about that. I would not think that that's the problem. .db. So now I need to do / right? That would be stupid. Nope. What is happening? We are not finding the database. But SQLite 3 database.db works. Hell. Cool. This says no such file or dictionary. Or directory, not dictionary. What the fuck is this? I don't think we even get out of this, do we? We crash before. We don't print this. Yeah. So we don't actually get the error down here, do we? Print p error y here. Heh. What am I looking at? What the fuck am I looking at? I get a Y here, and then I get a success. And then I get a fail to open database. Oh, down here. No such file or directory, probably. This is a failed to prepare statement. Okay. This works. Oopsie. Forgot where my B was for a second. Dot. Way to prepare statement, no such file directory. That means, I assume, what are we returning? Prepare returns SQLite. Okay. SQLite exclamation mark equals SQLite underscore okay. Okay. Nope, it's not okay. So guys, changes, when error occurs, return one of the error codes or extended error codes. Step will return SQLite errors. Can I reset? Error codes, can I print them? Result code meanings. There has to be like a function that prints them to a string, right? Standard result code for the most recent error. Oh. Can I do this in P error? RC? Nope. We do print F actually. One. What the fuck is one? Huh? What is one? Brother. Okay is 0. One error, bro. What? That is wild. P error. Okay. Why? Huh? Why? Why? No such file or directory. What file or directory? DB? Do you have a problem with DB? Pointer to DB. We have a pointer over here. So this is a pointer. Yeah, we're not passing anything wrong. Right? Open needs to pointer to a pointer, I assume. Pointer to a pointer, yes. What is your problem, brother? What are you doing? Why are you running? Why are you running? Add user. Statement null. What is that actually? Let me check again. Second argument. Later, blah blah blah. PZ tail is not null, then PZ tail is made to point to the first byte past the end of the first SQL statement. These routines only compile the first statement, so that is left point to whatever remains uncompiled. Okay, maybe that's the problem, huh? Weird shit. Okay. Wait, that's the constant char. Constant void, no, based. Constant void remains Oh, he doesn't like that. Oh, I know why. Remains, and we need the pointer to this. What expected constant char? Why do you say void? You are a character. Compile. There we go. Nope, still no such file or directory. Weird. SQLite prepare no such file or directory Let's see. Oh, do I need a dev version of this? Yay. SQLite 3 in div. Just not googling. Wait, no. That's not the problem. Happens when time, blah blah blah. Common errors and how to fix them. Database is locked. Encrypted or is not in database. Da-da-da. No such file. Direct file. Da-da-da-da-da-da. Yeah, no, I was here already. That is not the problem. Oh. This is kind of weird. Is this a statement issue? It shouldn't be. Let's see, did I fuck up the parameters somehow? Database. Int n bytes. You know what? Let's do the string length of add user. Try to +1? I don't remember. I don't know. Let's see. Nope. Still the same error. Nobody knows why. I'm gonna go to sleep. Fuck this. Bye bye.